Hi to everyone! I'm here to present you a distributed platform that will help doctors and researchers to diagnose and to treat the development and epileptic encephalopathies, a serious illness, especially when affects children. This work is a result of a project which involves several public Italian institutions. Among these, the author of this work belongs to Scuola Superiore Sant'Anna of Pisa, the Clinical Research Center Fondazione Gabriele Monasterio, and the Mayer Children's Hospital in Florence. I am Gabriele Cecchetti, a researcher of TESIP Institute of Scuola Superiore Sant'Anna. Development and epileptic encephalopathies are a serious illness and disabling condition, often associated with long-term comorbidities. They impose a serious medical and socioeconomic burden due to their high cumulative prevalence, early onset, and lifespan. The patients require lifetime support, and they are dependent from daily care. To support the clinical treatment of this disease and related research, it's important to have special clinical records available only for these, the times to help physicians cope with them. DECODE-EE is a regional project to develop a registry to support the clinical treatment and research about these. REMEDIES is a web application implementing such a registry. REMEDIES is the acronym of Registry for Developmental and Epileptic Encephalopathies and Medical Comorbidities. This registry allows the access and exchange of the medical data of patients affected by DEEs among 3 pediatric hospitals, which are located in Florence, Pisa, and Siena, and research center. The data contained in the registry are clinical textual data, reports, and diagnostic images. The DECODE-EE project partner decided to use an existing software platform for clinical data management to develop REMEDIES. Such platform is named Rare Disease Platform. This platform is currently used to support Rare Disease Network Registry of Tuscany regions and other patient registry. For REMEDIES, it was adapted to the project-specific objective in the area of genetic data entry and ontology integration. When the project will be ended, an enhanced version of this registry could be used at the national and international level, and it will be able to reach a wider audience. REMEDIES has several stronger features. Among these, it allows to integrate genotype and phenotype data of large cohort of patients with DEEs, including comorbidities and long-term outcome. It also allows to implement and standardize patient phenotyping, follow-up, management, and genetic testing. Build personalized treatment strategies and ad hoc surveillance procedures for the subset of patients who are predisposed to specific comorbidities. It will also let to analyze aggregated data to reduce direct and indirect costs for the community and help other scientific communities in the diagnosis and treatment of patients. Finally, REMEDIES may be integrated into external medical systems like electronic medical records. In these slides is outlined the REMEDIES architecture. The medical data about the patients entering the REMEDIES by the physicians and their recruiting centers are composed by instrumental data such as radiography, computed tomography, electroencephalogram, magnetic resonance, clinical data like clinical exam, information about epileptic and comorbidities, and the data from the genetic investigation method. This medical data is exchanged with external registries, such as the Tuscany Regional Registry of Rare Disease and the registry related to European reference networks, are used for the clinical and genetic diagnosis and for the follow-up of the patients. Furthermore, the interaction with the regional cancer registry allows to integrate the patient diagnosis and treatment. Finally, a PAC server deals with the exchange of the medical images. Let's focus now on some remedies rules. Different hospital or research centers can be allowed to manage the medical records of a patient. Medical records keep the clinical history of a patient, where some data can be entered once, some are follow-up. Physicians belonging to an hospital can access only to information associated to the medical records created and maintained within their own hospital. Aggregated data will be searched to extract correlations and useful information for the research activity. Moreover, medical record of a patient may be requested and exchanged between different centers. REMEDIES is designed to manage health data originating from clinical and genetic characterization of patients with DEEs. Hence, particular attention is paid to personal data protection. These requirements are addressed in particular by General Data Protection Regulation, and the data are managed and stored according to the highest standards in data management. Patient personal data is stored pseudo-anonymized. REMEDIES has natively access to the data of the regional database of all Tuscany patients served by the regional healthcare system. In fact, the Tuscany Regional Administration maintains a database with information of all patients who have been treated in any hospital of its territory. Each patient is identified by a unique regional anonymized identifier. Hospitals in Tuscany have access to specific application programming interface that allow to query such database and to get some personal data of the patients, including a unique regional identifier. Then the implementation allows the integration of other external providers of patients' information. In particular, REMEDIES platform has been used in a registry with a national and European scope, where a mechanism for patient identification at the national and European level based on national localized unique identifier for patient ID is implemented, ensuring the scalability of REMEDIES at international level. Moreover, REMEDIES has been designed and realized to be integrated with the external system, in particular the Tuscany Regional Registry of Rare Disease and the European Reference Network Registry of Rare Disease, according the following paradigms. If a REMEDIES patient is present in Tuscany Regional Registry of Rare Disease, REMEDIES can recover data from this registry, and in particular medical registration such as onset and diagnosis data, hospital where diagnosis was made for first time, therapeutic plans. Regarding the international system for European reference networks, REMEDIES can be easily configured to export reports with aggregated data as the result of specific queries. In REMEDIES, such aggregate data will be used to provide useful information to European Research System as Discovery, a research platform created by Leicester University. Discovery is going to be related to European Reference Network Registry of Rare Disease, such as Ithaca and EpiCare. Dedicated REMEDIES APIs can be configured to allow communication with Discovery in response to specific queries coming from the European platform. In terms of data modeling, the setup of registry has first required to describe the information that needs to be associated to the medical registry. This model is defined according to the requirements set by clinicians and researchers for the management of DEEs. Typical examples of entities in medical registries are anthropometric data, echocardiography, computed tomographic, cardiac magnetic resonance, and many others. Reports can be easily generated based on ad hoc queries and made available to specific user profiles in tabular form or through automatically generated graphs. Specific queries on REMEDIES dataset help physicians to extract relevant data in order to understand how disease and related comorbidities, also neoplastic, are combined and evolved over time. Identify specific strategies for detecting low-level mosaicism in diagnostic procedures. Improve knowledge on disease genetic determinants to implement genetic screening and develop personal management, surveillance, and treatment paths. Develop in the future novel drugs for disease treatment. Another goal of the DECODE-EE project that contributed to REMEDIES development is to give a particular focus to the subset of patients requiring personalized surveillance path, like patients carrying a specific mutation in their genes who have an increased risk to develop tumors, as well as patients with already identified neoplastic comorbidities. REMEDIES will also allow to declare the kinship among different patients. This came handy in REMEDIES since relatives of patients with disease and with confirmed genetic diagnosis will be tested for variants, and, if positive, their data will be included in REMEDIES even if they are asymptomatic. So, all recruited patients with a family relationship will be stored in REMEDIES, using a specific mapping to account the degree of kinship, so that a physician can easily check and extract the related information. REMEDIES also allows to harvest information on neurological and other comorbidities. This task is addressed integrating the human phenotype ontology and orphanet ordo ontology. A widget for each of the above ontologies assists the users while they enter data in the system, including a completion or a pre-offer on a menu based on the data to be entered. For example, let's see the three figures on the right. From the top to the bottom, they represent, respectively, the phenotype selection from Human Phenotype Ontology database, the orphan code of the rare disease, and, in the bottom, the menu of comorbidity associated with the individual medical record. REMEDIES provides for data and service integration in order to facilitate gene data entry. Two datasets are integrated in REMEDIES. The first one is the human genes according to the nomenclature approved by the Hugo Gene Nomenclature Committee. The other one is related to human genes coming from online Mendelian inheritance in man. This dataset is continuously updated catalog of human genes, genetic disorder, and phenotypic traits with particular focus on gene-phenotype relationship. REMEDIES can store patients' genetic data, including the name of mutated human gene and the genetic variant identified in each patient using the sequence variant nomenclature. These features are implemented and exploited in REMEDIES with a couple of widgets. The first one is a gene data entry whose user interface is shown in the top right figure that, while the user types, triggers a query to search best match in AGNC approved symbol and names, AGNC alias symbols and name, OMIM phenotype description yielding the genes associated. In the resulting list of matching records, along with the approved name of the genes, the user obtains detailed information that helps checking if the data entered is correct. In fact, each matching gene will be represented with approved symbol and name, list of related phenotypes, OMIM title and alternate title. A further REMEDIES widget allows to search for gene sequence variation, while the user types. When the user hovers over a gene, another query is run to retrieve the associated transcripts, as you can see in the bottom right figure. Once the user selects the desiderated transcript, it's possible to complete the variant by typing it. A web service is then invoked to verify the syntax of what has been typed, as you can see in the figure on the top right of the slide. If the syntax is correct, another web service is invoked to run a semantic check, as you can see in the figure in the middle of the slide. When all data are entered correctly, the protein description is shown and the link to the relevant gene page on the OMIM database is made available, as you can see in the figure in the bottom of the slide. The use of a standard picture archiving and communication system allows the direct integration with the various hospital networks without involving the IT system of the hospital. In fact, the standard DICOM protocols used by the PACS allow the REMEDIES registry to be transparently integrated within the organization for any hospital. Such an integration is possible because DICOM is the internationally recognized standard for the representation and communication of medical image data and signals. The involved research hospitals are therefore already compatible with REMEDIES and can distribute and review imaging data without any change to the internal organization or specific software adaptation. The PACS communicating with REMEDIES is based on DICOM for Share package as Image Manager image archive software. The PACS has been configured to be interoperable with REMEDIES registry. REMEDIES store the diagnostic images into the PACS by using an ad hoc developed intermediate software system which provides the verification and pseudonymization service as shown in the figure of these slides. In this way, REMEDIES, the intermediate system, and the PACS system are isolated from each other. REMEDIES is the only system where it's possible to associate the patient data to diagnostic images, and the PACS is secured to containing only pseudonymized diagnostic images. On the right of this slide, you can see the upload web interface of the developed intermediate system that allows the operator to upload the diagnostic images into the PACS. Here, DICOM files and archive of files can be uploaded through an easy-to-use drag-and-drop interface. Status bar and informational button show the current status of the uploaded images. Let's see now the workflow for uploading images into the PACS. First, the doctor or the assigned operator inserts the patient data into REMEDIES, which generated the three patients identifier, patient names, patient ID, and accession number. When the operator initiates the process to store the diagnostic images, REMEDIES alerts to avoid submissions of images containing impressed personal data. Such warning is necessary because the intermediate system takes care only to removal of structured data from the header of DICOM files. Then REMEDIES redirects the page to the intermediate software which provides for delivery of DICOM images into the temporary storage. In the step 3, the intermediate system analyzes the received images and replaces any sensible data contained in the headers with pseudo-random identifiers that perceive the association of these files with REMEDIES patient identifier. Finally, when all the images are safely stored in the intermediate system, the latter uploads them into the PACS. In this presentation, I showed you that REMEDIES is a web-based registry for patients with DEEs. The registry collects data of large cohort of patients being accessed by 3 different hospitals in Tuscany and by external registry. REMEDIES is also connected to a PAC subsystem to store diagnostic images, taking care of pseudo-anonymization of patients' data. REMEDIES will add to standardize patient phenotype, follow-up, management and genetic testing, as well to develop personalized treatment strategies, ad hoc surveillance procedures for these patients who are predisposed to specific comorbidities, as well as the analysis of aggregated data to reduce direct and indirect health costs. In the future, this work may be further improved with the automation of described architecture and potential involvement of machine learning features to aid the diagnostic and treatment of the interference process. Thanks to everyone for your attention.